Hello, let's continue our advanced Sudoku series with Two-Winged Angel by Philip Newman. I think this must be a reference to One-Winged Angel from Final Fantasy VII, but most angels have two wings as depicted. So that's pretty funny. But I guess it is an angel and it's got kind of like two wings. I can see it. All right, so this puzzle is puzzle number 2 of chapter 4 of the Sudokult Gospel document. You can find the link to that document in the description. As always, I know what technique I'm looking for and how it works, but I do not know where it is in this specific puzzle. That way I make sure I find the correct thing and I'm able to explain it. But it is a quasi-live solve otherwise. There is a link in the description if you'd like to try the puzzle yourself first, and I'm going to get started right now. All right, well, this is a 1-2. I'm going to fill all of these boxes that have 4 left. All of these. And then these rows as well. Okay, so this column needs 1, 2, and 8. This row needs 1, 2, and 5. This box needs 1, 2, 3, and 8. The 8's in one of these two. That puts an 8 in one of these two. This box needs a 1, 2. We have 3, 4, 5, 6. We need 7 and 9. Okay, so 9's in one of these two. Yeah. 8, 1, 2, 3, 1, 2. Okay. What other scanning can I do? Oh, these 4 and these 4. Okay, so 1, 2, 3, and 5 go here. So the 5's in one of these two. That puts a 5 in one of these two. Oh, we have a 1, 2, 5 triple actually. So this is a triple then. This is 5, 7, 9. It's not a 5. No, wait, not 5. Sorry. Whoops. 1, 2, 3, 4, 7, 9. 4, 7, 9. Okay, so that's a 4. These aren't 4s. This column has 4 left. 1, 2, 3, 8. Okay. 8's in one of these two. What can this be? This can be 1, 2, can't be 3, 4, 5. Could be 6, can't be 7, 8, 9. Okay. 7, 9 pair, 1, 2, 3. Looking to see what else I might be able to do here. Maybe we should scan a little bit. Oh, how about this box? We need 1, 2, 4, and 6. So 6 is up here. Okay. 2, 3, 5. I've got 2 4s looking up here. So 4 is in one of these two. I've got 2 5s looking up. So 5 is in one of these two. Okay. I feel like I should have enough at this point. Anything to do here? Scan these 7s. 7's in one of these two. 6, 5's in 6. Okay, so 5's go in one of these two. 6's are up here somewhere. Don't really want to mark that. 4's as well. Okay, 4 is in one of these two. So is this a 4, 6, 7 triple? Yeah, this is a hidden 4, 6, 7 triple. Oh yeah, we have a 1, 2, 8 here. 4, 6, 7. Should have seen that. Oopsie. Meant to remove the corner marks. So 4, 6, 7 triple. This is from 1, 2, 3, 5. Cleans up a little bit. These are from 1, 2, 3, 8, 9. So the 9's in one of these two. Okay. So anything else I can find? I mean, I feel like I have most of the puzzle penciled by accident. All right, what should we do here? Okay. I'm looking. Got this 1, 2 pair here. I feel like it's gotta be related to this plus sign here. Okay. What I'm investigating right now is in this column, one is in one of these 3 cells, and in this row, one is in one of these 3 cells. Feels suspicious to me. Same with 2, both 1 and 2. And this has to be a 1 or a 2. Feels intentional to me. What can I do with that? Can I... We talk about the 1s and 2s in green. I think so. I'm wondering if it makes that an 8. Okay. Does it? So I've got these 2 rows and this column. The problem is they intersect here. So I can't... Okay, so... Ooh, yeah, all I've proven is I need a 1 or 2 over here, and I don't think that works. Am I using the wrong thing? These rows, I could use this box. Okay, so... What would my base sets be? I don't know if I want to use these. One, two feels key, of course, just based on how this puzzle is constructed. This column, maybe? No, this column also intersects with this row. How do I deal with that? It's kind of like a grouped 2-string kite almost. Not really, though. This is not allowed to be a 1-2 pair. Because if this was a 1-2 pair, this would have no value. That could be double 1 or double 2, though. Ooh, can it? No, it can't be double 1 or double 2, because that breaks this box. Because if this is double 1, we don't get to put a 1 in this box, right? Same with 2. So there is a 5 or an 8, at least, in this cell. There's like a strong link between this 5 and 8. One of them, there's a 5 or an 8, or both. Is that important? I want to investigate this. Okay, so if my base set is these 2 rows in this column, then I need to be able to cover them with 3 other houses. So I could cover... The thing is, I don't care about 1 and 2 here. So if I just ignore that, that's fine. And I can ignore here because these can't be 1 or 2. And then I could do... I could do a box for here. I still have 4 boxes left. I feel like this isn't quite right. All right. And plus they overlap, which I think it might be invalid. So let's find something else. I think this... Maybe I use this box as one base set. Then I can use this row as a base set and this column as a base set. They overlap here. Is that a problem? So I don't care about these cells. I don't have to actually cover them because they can't be 1 or 2. So I can cover all the 1s and 2s. How would I cover these? Don't care about that. Don't care about these. I need to cover the green with 3 houses. Okay, well, if I did this, I'd have a fin. So if I cover with these 3 columns, I already used one of these columns as a base set, though. I can't cover it with the same cover set. I use these. So I could cover with this box. I used this box already for my base set. I didn't use this column, and I didn't use this row. Okay. So what can we say about what I just did? I used this row, this column, this row, and this box as a base set. Then I was able to cover all the 1s and 2s with purple. But I'm worried about this cell getting double counted. It is only a 1 or a 2. So we know that it is a 1 or 2, and it was double counted. Okay, so the green is going to contain 3 1s or 3 2s, and then 2 of the other one. And that's going to eliminate that 1 or 2 from these cells. So whatever isn't here gets eliminated from these cells. And this cell. That's kind of interesting. So whatever ends up in this blue cell here, the other one, the one that isn't this one, ends up 3 times in green. The 1 or the 2 that isn't blue ends up 3 times in green, and so it can't be in these cells. So blue ends up in those cells. Wait, does blue end up in those cells? I don't know. What's the conclusion? I'm not sure there is one. I'm not sure there is one. Okay. It's the double counted. It's really getting me. I feel like I'm on the cusp of understanding what to do here. I've kind of done a virtual elimination from these cells. Whatever isn't blue. So these cells could be blue, but they can't be orange. I don't even know where to mark orange. But yeah, one of these 2 is orange. And orange is not in these cells. So there's a virtual 1-2 pair in here then, right? Is that true? Or this could be 5 and 8, right? No, because if this was 5 and 8, then I wouldn't be able to fit 3 of the non-blue 1-2 into these green cells. So the non-blue 1-2 does go here, which means that none of these are 1 or 2, because the blue one is here and the orange one is here. In addition to that, these are not orange. So if I get rid of my colors at this point, what I have learned is this 1-2 is blue. There is an orange 1-2 in one of these 2 cells, and these cannot be orange. These are non-orange. But I think the important thing is none of these are 1 or 2. And so these are from 3, 4, 5, 7, 8. We can clean that up a little bit. That makes this a 3. Wow. Okay, so that's a 3. Naked 3 now. We can deet dude in the corner. That's not a 3. So 3 here is placed. Very interesting. Okay, that's not a 3. So 3 here is placed. Okay, what else can I do? Anything else with 3s? Yes, 3 is placed in this box here. 3 is placed in this box here, which places the 8 as well. 3s are done. Wow, okay. So that was it. That's crazy. That's 8, that's 9. This is from 1, 2, 5, but it's not 5, it's 1, 2. Okay. You know, remember when I said that one of this was 5 or this was 8 or both? It can't actually be both, because if it was both, then we'd have too many 1, 2s in this box. So actually, there is a 1, 2 in one of these two. So there's an orange in one of these two as well. Interesting. So we've got kind of the orange and the blue accounted for. We've got 2 oranges here and this blue, which is kind of interesting. What does that do? I don't know that that does any more than we already figured out. I'm trying to finish this puzzle though. So what do we need here? 1, 2, 6, and 5. This can't be 2 or 6. This is 1, 5. This is 1, 2, 6, 5. 1, 2, 5, 6, I should say. 7, 9 pair, 1, 2, 5, 1, 2, 4. Can I do anything else here? 7's in one of these two. Is this a 1, 2 pair by any chance? I don't see why it would be. Doesn't have to be. Let's see. What else can I do here? This cell is from 1, 5, 7, 9. It's not a 9. Okay, so 9 in this row goes here. That's a 7. These aren't 7s. Did I get a 1, 2 to match up with? No. 1, 2, 6. These are from 1, 2, 6, 7, 9. Ooh, 7 has 2 places to go. Okay, how about this column meets 1, 2, 6, 7. 1, 2, 6, 7. These can't be the 2. Right, so 2 in this column goes here. That's a 6. That's good. That's 1. That's 5. This is a 2. And blue is 1. Okay, so we now know that... Yeah, we get the 5 here. And then I know that this cannot be the 2, because we said it was non-orange. I'm pretty sure that logic was correct. Okay, so this is now a 4, has to be. This is 7 and 8. That's a 1 now, because it was a non-2. That's a 2. We get the 1 and the 2 here. We get the 8 and the 2 here. So we did end up with 2 2s in orange. Good. That's not a 2. That's not a 6. We get the 2 here. We get a 1, 5 pair. Down here we get a bunch of digits. 2, 1, 2, 9, 7. That's a 5 and a 7. These aren't 2 or 5. That's not a 7. We get the 6 here. It finishes these. Get the 4 and the 7, the 1 and the 4, the 5 and the 1. Down here we need 5, 6, and 9. So this is 9. This is 5. This is 6. Nice. So yeah, it looks like I did find the thing I needed to find. That was cool. So that's called a finned mutant swordfish. And I think the fin was actually the fact that this cell was double counted in our base sets, which means that it did not need to appear 3 times. But the one that, because both 1 and 2 were limited to the same fin mutant swordfish, the other one, in this case, because this ended up a 1, the 2 did need to end up in that 3 times. So if I actually look at this again, if I do this box as my base set, this row and this column, then what I said was essentially the 2 needed to appear 3 times in green. And because the 2 needed to appear 3 times in green, it had to end up in one of these 2 cells. So it couldn't have been here. And then also it had to end up in one of these cells, two of these 4 cells, which meant that it couldn't have been in these 2 cells. Because we would have had a 2 in one of these 2 and a 2 in one of these 2, right? So it couldn't have ended up here. We didn't know what to call it yet. We had to call it orange because we didn't know what this would end up being. But because now we know this ends up being a 1, we do get 2 3 times in green. It has to be 3 times in green because 1 is taking the only slot that it could have taken up in order to not appear 3 times in green. And because of that, and because we were limited to these cells, we got a bunch of deductions from that. Because we could cover it with, we used this cover set, and then we used this cover set and this cover set to cover all the 2s. And so these ended up not being allowed to be 2, and these ended up not being allowed to be 2. But we had to call it orange until we knew what it was. But we knew these wouldn't end up 1 or 2 because either this ended up a 1-2 pair or this ended up a 1. Well, actually, we knew this would be a 1 or 2. So we kind of knew there was a whatever this digit was, the other one ended up here. That's what we knew. And so either way, these couldn't be either 1 or 2. That's really cool. So yeah, that was 2-winged angel. Really cool idea, Philip. I enjoyed that. Good execution as well, because I managed to find it with my first attempt, which is, well, it wasn't quite the first attempt, but it was an early attempt. And so this is how you can kind of, once you understand a really generic way of understanding something like a swordfish, you can start fiddling with it and doing really cool things with it because you understand the underlying theory of why it worked in a way that's very generic. And so it's like, why do I need to use 3 rows versus 3 columns? Why can't I do a box and a row and a column against a box, a row, and a column? As long as I have 3 base sets and 3 cover sets, and I understand fundamentally how that works, I can then reason about things like fins like this. So that was neat. I think that would be called an endofin because the fin is within the fish as opposed to an endofin where the fin is outside of the fish. But anyway, that was really neat. I hope you enjoyed it. I certainly did. If you did, then why not leave a like, subscribe, and a kind comment below.